Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today we're going to talk about setting up a mooring for a self-stable buoy and establishing the steady-state deflection. So we're going to use the Fugro Sea-Watch LiDAR buoy as an example. This spec sheet for it here online. It's an example of a self-stable buoy that can be used with a low-tension mooring. And it's reasonably sizable, 2.5 tons and 3-meter diameter. So we're going to work with ProteusDS Oceanographic Designer here and create a sample mooring. This is going to be a low tension mooring. It's not based on a real mooring. It's just an example of a mooring with a mid-water float and a low tension tether to the surface buoy. We're going to leave the environment properties water depth at default. I think this is a little bit extreme for an ocean current, so we'll change that to 0.3, tapering to 0 at 1,000 meters depth. And first we're going to just add a strong but neutrally buoyant Samson rope, Amsteel blue, just starting with something to begin with. We'll get this almost to the water surface, the mid-water float, just for the purposes of getting something going. We're going to use flotation and a mooring system's 35-inch syntactic sphere. We'll add another tether to the surface. So we'll say this is 100 meters. So we've got a total mooring length of a little bit over 1,000 meters. This is again just demonstrative to see what's going to happen to this buoy. So we need the surface buoy as well. So add our final assembly, top buoy. Now we don't have the floating LiDAR buoy in the parts library, so we'll have to add that. Now I've got my top buoy assembly. You can do that through the parts library editor here by going to add, and we'll click surface buoy. We've got an interface here. Now Oceanographic Designer allows you to make point models of buoys. This works really well for most oceanographic moorings for buoys that require a mooring load to keep them stable. This is where things get a little bit different, especially with something like a floating LiDAR buoy where there's a lot of mass and not necessarily a lot of mooring tension to keep it stable. They have to be self-stable, but we'll show what that looks like in a minute. So we pick the form factor. It's going to be cylindrical. This is what I like about this buoy, is it can be well approximated with a cylinder. We've got a nominal diameter, 2.9 meters. Cylindrical buoy length. This looks about sort of a 1 meter dimension. I don't have the full spec. I'm just kind of eyeballing it. Connection offset, this is how far off the mooring connects from the bottom of the buoy. And we've got our mass of 2,500 and the net buoyancy, 2,180. We'll call this LiDAR buoy. And create it. And we're going to select that newly created. This is in our local parts library now. All right, so we've got our basic design. I'm going to save this. Here. We'll export it and run a static analysis in that current profile. So we've set it up, and we'll check the results in a minute. So it's just taken a minute or so, and we've got our static mooring deflection. So we'll load the results here. So there's the buoy and the initial mooring state. It's a little hard to see the whole mooring, so we'll go orthographic view. Select the east perspective here. so the current's going by default left to right across the screen. So we've got a slack portion of the mooring here. Just look at the tension. This is the 2 kilonewtons, sort of pretty static tension from that syntactic float. And then we've got the deflected mooring profile here, and you can see there's where the subsurface float is, and we've got a very low tension portion of the mooring. Now the issue here is, because it's so low tension, and the way that a point model is for a cylinder or a sphere is modeled is it uses the local tilt angle of the mooring for the tilt angle of the buoy. So it's alright just to get an initial deflection of the system, but that's not really representative of what the buoy would be doing, and that's when we need to get into a rigid body mooring. Rigid body buoy for the buoy and connect it to the mooring. So that's what I wanted to show right now, is just initially how to get this deflected state. Next we're going to show how to replace this buoy with a rigid body model.